we talked about concentration a little bit. We said that there were kind of two levels that describe a solution's amount of solutes. We said if there's a lot of solute, that something is concentrated. We said if there's not a lot of solute, we said that that's called dilute. You don't have to draw this, but I do want you to look up here for a second. On the board, I have two different beakers. Which one of these beakers would you say is concentrated with solute? The one on the right, right? How'd you know that, right? There's more dots. There's more solutes in it. If that one's concentrated, what do you think the one on the left is? Dilute. Not a lot of solute. And on Monday, that worked for us. We could simply say, oh, that one's going to be dilute, this one's going to be concentrated. But today, we're going to add some stuff to that. See, we can't just be as vague as we were on Monday. We're going to get a little more specific. Today, we're going to learn how to count some dots. I believe y'all did a lab last semester about counting beans.
Yeah.
Oh yeah, we had to like.
It bring back memories.
Yeah, you guys are going to do that again.
Oh, what?
No, I'm just kidding. I'm just kidding.
That was terrible.
It was just a ha-ha, hee-hee-ha. But we are going to learn how to figure out how many dots, or in real world chemistry, how much solute is in a solution. Now, you've been using this all semester long with me in every lab that we've done. You just didn't know it. When we made chalk, you made solutions of certain concentrations. The solubility lab that we just did yesterday, you made solutions of certain concentrations. You just didn't know it. The reason you never knew it is because you never cared. You didn't know what the term concentration meant, but you're going to learn what it means today. Today's very math heavy. You're going to want to make sure you have your periodic table, your calculator. You may want your stoichiometry roadmap if you do not feel confident in your stoichiometry. But today's stoichiometry problems are only going to be one step, so it shouldn't be too bad.
So, when this stoichiometry like leave and like never come back?
It doesn't the rest of the semester.
Oh.
So actually, goodbye.
So actually, I'm dropping out.
So actually,
I'm dropping from a cliff.
Oh.
Not dropping it.
Alright.
Will said I looked like I was from Harry Potter.
What does that even mean?
I corrected him and I said this would be Ravenclaw and Hufflepuff. So you're actually wrong.
Oh, because he's right.
You idiot. I have a test today about internal combustion engines, and I don't know anything about that.
She said this.
I'm just a girl.
Why do I see 80 letters?
Yeah. For the lab, we had to have paired partners, and let's just say it got a little bit heated yesterday.
Scream.
Ethan. I got mad at him. Doing the lab wrong.
hey, y'all have this written down?
Give me a calculator.
There's no direction.
It says hand me, not throw me.
Okay, does anybody else need a calculator?
Ethan thought about grabbing it for you.
Okay.
Ethan did not.
Can we start doing examples?
Just like not. Yeah. First sentence was my room.
Can I write that down? No?
Hey, write this problem down, please.
The first ingredient in this is carbonated water. So it's just like what you're drinking. If you actually
Hey, in this lesson, your units are going to be super duper important. As is following my formula very closely. I want you to look at my formula that I have up here for a second because it's a little different than the one you just wrote down. The difference is that mine is a little more specific because it's going to help you for the first few problems that you do these to make sure you don't get your wires crossed. Your formula that you wrote down said something like this. It said big M equals moles divided by liters. But it's important you know moles of what and liters of what. Make sure that you know the moles part in that formula is always going to be talking about moles of solute. The moles of your solute. The big L stands for liters, and it's always going to mean liters of your solvent. Your solvent, almost 90% of the time for you guys, is always going to be water. Okay? So it's almost always going to be moles of solute over liters of water. But then we need to also define what big M means, because that's something you guys haven't seen yet. Big M stands for a new unit called molar. Kind of like your molars in your mouth. MOLAR is what big M stands for. Molar is the unit for concentration or molarity. Okay? Concentration and molarity are the same thing. They're just two different names for the same thing.
You say kind.
What?
You say chemists are lazy, but why do you guys have so many names for like the same thing?
You say you guys were lazy, and then you're just like introduce us to the most complex thing I've ever realized before. Oh my god.
Well, that's the reason that we're lazy, because we have to do hard math, and then we don't want to do anything else.
Yeah. Wait, chemists are lazy and they leave off like the ones and stuff, but yet y'all still care about like labeling and stuff. Like,
Oh,
units.
labels are so important.
Are
Units
they?
are the most important thing. All right.
No, like abbreviation.
Hey, let's do this first problem.
Alright.
It says, what is the concentration or molarity of a solution of 3.8 moles of hydrochloric acid dissolved in 2 liters of water? Hey, with my word problems, y'all remember what I always like to do? I always write my list of my givens, right? Make your list of your givens. In our case, Gage, what's my first given?
3.8 moles of HCl.
Yeah, we have 3.8 moles of HCl. Hey, which one of these variables do you think that's going to go to? Oh my goodness, it's a crazy concept. Moles goes with moles.
I feel like, why would they just leave off the E, bro? That's crazy.
Because chemists are lazy.
Like, to leave off an E, one more letter?
You know how many times you write moles? Hey, what's my second given, Emery?
2 liters of water.
Yeah, 2 liters of water.
Well, technically it's 2 letters because moles is
Claire, what am I solving for here?
the concentration,
AKA the.
molarity.
So which one of these variables means molarity / concentration?
M.
Big M.
I thought he was gonna say it meant Big Mommy because he had the Big Daddy
Yeah, the
rules,
Big Daddy.
so he had Big Mommy.
No. All right. You know my favorite way to do these problems is just a simple plug and chug. Rewrite your formula. We have big M equals moles over liters. Plug your numbers in. We'll have big M equals 3.8 divided by 2. Put that in your calculator. Tell me what you get. I get 1.9. Hey, but I'm missing something. I can't just walk around the halls butt naked. I need a unit. What's my unit going to be here? Yeah, you can say moles over liters. That's one way to write it.
Okay, Ricky.
Moles over liters. The shorthand way to write that and the easy way to write that is just the big M. Big M stands for the word molar. Molar is the unit that we use to measure concentration. So in next week's lab, y'all are gonna make your own solutions, while you have to do these calculations to figure out what concentration you have. you're gonna write a number and then a big M. So like 3 big M. That stands for 3 molar, and then of whatever chemical you're working with.
The way you are, the way you understand, the way you move, the way you just whisper me, the way you talk.
Hey, everybody look back here for a second.
Oh my gosh.
This gallon jug will kill you.
Great.
This is sulfuric acid. But we can't just say sulfuric acid anymore because now we're acting like good chemists and we're going to talk about concentrations. This is 18 molar concentration. This stuff will burn through your skin and your muscles in like 20 seconds, if that. Like if I were to like drop a couple milliliters of this on your head, GG's.
Oh, GG.
So I don't like that you have access.
What does that mean?
GG's?
Okay.
Good game. Like that's
Yeah,
it.
but why would you
Game
say
over.
good game?
But,
Like
what-
you're gone. You're done.
Well, why? Just say G-O.
Okay, whatever. The point is, 18 molar is super duper strong. It's one of the strongest acids in the world at one of the strongest concentrations it can possibly be. Whenever you're in the double numbers for concentration, you're pretty strong. Like that stuff is dangerous. Down here, we're at like 1.9. It's not fun by any means, but it's far less dangerous. Like that, I would let you work with 1.9 molar sulfuric acid. As a matter of fact, you probably will work with that next week. However, I would never ever let you touch 18 molar sulfuric acid. If you were to even touch that bottle, I could get arrested for child endangerment. So, fun facts about
Then why
chemistry.
would you put it so close to Gage?
It's on the other side of the laptop. Gage, don't touch the
I
bottle.
won't.
Okay, questions
I'm
about
like a child.
questions about that.
No, I won't.
All right, let's do another example.
So that was it?
Claire.
Huh?
Don't say that because it's gonna get harder.
It will get harder.
But like how much harder
Claire,
on a
why do
scale
you
of
have
1
to
to
say
10?
that?
Well, considering we still have to do the stoichiometry questions,
No.
Can't we just like not?
numero dos.
So you like put sulfuric acid in your squirter bottle for your period
Yeah,
setting?
if I wanted to get arrested for like a murder charge.
Could be attempted murder.
It would be like,
You don't
yeah,
like
like
smell?
Also, your
third.
skin doesn't like burn, like as in like because
Like
third
if that
degree-
stuff got on your hand, the hospital could not save you that hand.
Ah.
It would simply be nothing. Like it would
So
look
then,
I just
like-
didn't know if it like gave you like a
You
third
could go to
degree
the
burn or
Paralympics
something
and
where
you
you
would
just
have a
wouldn't
better
feel
chance.
anything.
No, it would just take away your hands.
You just
You would have no
look at
hand.
the bright side of life. I mean, it would suck, but there's always a way. Man, it is so. I really like it.
Number 2, how many moles of sodium phosphate are in 5 liters of an 8.1 molar solution? 8.1, definitely a lot scarier than 1.9, but definitely not as bad as 18. Okay. Casey, what's my first given in this question? She says 5 liters. Which variable is that going to go with? Just, yeah, 5 liters. Liters of solvent goes with liters of solvent.
No, actually it goes with mole. I'm sorry.
Ethan, what's my second given here? 8.1 molar. Do not get molars and mole confused. Molar and moles are 2 very different things. Hey, that means I'm solving for moles here. Do we all agree? The problem even says how many moles? Most of you may have worked ahead of me and might have this done already. It's very similar to what we just did. Always start with your formula, where we will have molar equals moles over liters. Plug in, we'll have 8.1 equals X over L. In our case, that's 5. How do I solve for X here? Multiply both sides by 5. Do we all agree that you get 40.5 moles of Na3PO4? Make sure you are specific with your units. Make sure you write your chemical name, sodium phosphate. How do we feel? On a scale of 1 to 18 molar, 18 molar being you feel really good, really strong, 1 molar, you feel very weak, very dilute.
17.
Okay. 16,
17 and a half.
17 and a half, okay. What's the number 3? I'm about to dilute you guys down a little bit, I think.
What do you need?
What? Says how many grams of NaCl are there in 0.300 liters of a 4.5 molar solution?
Okay, I have to leave.
You wish.
Come.
How many grams of sodium chloride are there in 0.300 liters of a 4.5 molar solution? Sig figs. Where am I at? Reagan Clark, what's my first given here?
Excuse me.
LSU.
0.300 liters.
Thank you.
You're welcome.
Hannah, what's my second given? 4.5 molar. Reagan Ferris, what am I solving for though?
Moles.
I disagree.
Grams.
I need grams.
Oh no.
Hey, but look, the problem's saying I need grams, but there's no grams in my formula.
Then why didn't you give us a problem?
But using our formula here, hey, look, using my formula, can I solve for moles? Do I know how to convert moles to grams? I sure do. Stoichiometry. So the way that I write this is like this. I need to use moles to find grams of sodium chloride. Let's start with finding moles here. I'm going to use my molarity formula, where molarity equals moles over liters. My molarity, 4.5 equals, I'm solving for moles, so we'll put next. Liters, 0.300. How would I solve this? Multiply by what?
Multiply the x and the 0.30 by
Multiply
4.
both sides by 0.300. What do you get when you do that?
1.35.
1.35. What's my unit for that?
Moles.
Moles of what? So we're at moles of NaCl. Am I done? No, I'm halfway there. I've got the moles part. I just need to get to grams now. Hey, who remembers how to set up a stoichiometry problem? Start with your given. In our case, our given here is going to be what we just solved for. So 1.35 moles of NaCl. Draw your grid. Hey, the good thing here, your grids are only going to be one step. We're keeping it nice and easy.
Okay, alright, okay.
Hey, if I have moles of NaCl here, what am I going to have down here? Moles of NaCl. Am I able to just go straight from moles to grams? Yeah, sure am. We're not changing compounds. There's no equation. We're just doing a moles to grams conversion. Every time I see grams, where do I get that number from? From the molar mass. Periodic table mass, what is it? What's the periodic table mass of sodium chloride? I'll save you some time. It's 22.99 plus 35.45. I get 58.44. What am I going to put down here for the moles? Just one. Plug that in your calculator, run your grid. What do you get? About 78.9. My unit is grams of NaCl. Now, technically, that number is not 100% right. We should only be rounding to 2 sig figs here because our least specific given was 2 sig figs. I'm not going to count you off
Oh, okay.
for sig figs this year.
When we do our tests, is this one going to be Gonna get the last one.
Haven't decided yet. Maybe. I'll think about it.
Is this as hard as
I don't know.
No, you do
Yes,
know. I know you do know.
That's the thing. You do know.
So number 4. Hey, work with your shoulder partners to try and finish this. We're gonna go over it here in a couple minutes. Ethan, you can work with these 2 clowns.
Ethan's just gonna tell us we're wrong.
Probably. He's probably gonna be right.
No. No.
What about Reagan? You're just gonna leave her alone.
Reagan,
back
you can
there?
work with girls.
Wait, so we're
Ethan, are you gonna come over here?
okay.
Okay.
Be back. All right, so let's look at my givens here. I've got my first given I see is in grams. I can't use grams in my formula, but I bet I can maybe convert moles or find moles using grams. My second given looks like I have 0.0392 molar. Hey, is this a dilute solution or a concentrated solution? How'd you know it was dilute?
Small number.
Very, 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 very small molarity. It's practically almost water, okay? I'm solving for volume. All good so far? I'm gonna have to end up calculating moles using my grams, which means I actually need to start this problem with my stoichiometry.
Stoi's right.
I never said you were wrong.
Oh,
Ethan did.
Yeah. Oh yeah.
What do we get for our molar mass of K3P? 148 point what?
27.
I agree. What do we get when we type that on our calculator? Hopefully somebody says 1.09.
Yeah.
We tracking?
Yeah.
What's my unit here? Moles of K3P. So now that I have moles, I can finally solve for my volume using the molarity formula. What?
It's 1.02. Yeah, it's not 1.02.
Hey, yeah, you're right. Isn't it?
Bruh. Casey told me.
I did not say anything.
Everybody makes mistakes. You just have to admit to them, and that's how you learn.
Yeah.
Yeah, Casey.
What?
No. That was for you. My inspirational
No
speech.
one
That
heard
was for
me say
you.
anything. No.
I didn't type it in.
No.
I'll type it in.
But you said it should be 109. Did first period lie to you? Well, I sounded like a smoker.
I guess I'll type this one in. Can't trust anybody.
Not even yourself.
The mind can play tricks on you. It's a very powerful thing.
Multiply both sides by x.
Oh, there's hair in my eye.
And I got 26.0 liters.
Yeah, it makes sense now that you solved it.
We good? Do we feel like we need to do another one?
Wait,
Wait.
I thought we were supposed to solve for
I mean,
volume.
now that
We
I
did
see
solve for
liters
volume.
volume?
Liters is the unit per volume.
Oh, okay.
What? What'd you type in to get the 26?
1.02 divided by 0.0392.
Okay.
Okay, there's only one other thing I want to point out to y'all. We're going to do a fifth example, but it's okay. Okay, what do you notice about this problem? What's an extra step you'll have to do? Yeah, we have milliliters here, right? I gave you milliliters of solvent, but what do I need? I need liters. Do we know how to convert from milliliters to liters?
1,000 milliliters is 1 liter.
1,000 milliliters is 1 liter. So how would I convert 376 milliliters to liters? Divide by 5. Okay. Peace.